Okay, just a little bit of a tricky one. This because it's so theoretical. Okay, that's our biggest problem. So again, we see it's two rationals being divided. So first thing I'll do is examine this first one here. Now, believe it or not, that is the very definition of a perfect square. Because you go back to what we talked about in class yesterday when we had x squared plus 8x plus 16. You and I said that was a perfect square. And the reason we said that is because that's 4 squared, that's x squared, and two 4s were 8. So that formed the perfect idea of a perfect square. So if we look at what we've got here with this a squared plus 2ab plus b squared, if you look what that middle term is made up of, b squared, square root of b, that's b, that's a, and the middle is 2 times AB. So this is actually a perfect square. So that's how that factorizes. The denominator here is already factorized. We know we're going to have to flip it. Now this is another perfect square, but with a difference. Now a squared minus b squared. Look, to be brutally honest, it's not something we've done in class, right? So it's a number of girls have seen it. I did demonstrate it in class yesterday, but that's what is required there. The difference, this is what's called the difference of two squares. And you can see why. It's the difference of two square numbers. And that's how it factorizes. If I was to extend that idea a little bit out, just say I had that. That's the difference of two squares, which we can automatically factorize. It's very, very similar to a perfect square. Now, just to be completely honest, these questions are probably beyond the scope. That's why they're called challenge. They're beyond the scope of what we are required to know for this upcoming exam. But it doesn't mean we can't have a look at them. So now what I would do is to cancel and to see what is possible. To help me with that, I'm going to put a new line in. I'm just, to make my job a little bit easier, I'm going to write out what a plus b all squared actually means and what a minus b squared actually means. I think that will make my job a little bit easier when it comes to cancelling. So top and bottom, well, that can go with that. That can go with that. That can go with that. And ultimately in this one, I'm left with a minus b on a. So that would be it. However, just as a cautionary tale to what you're doing, and the fact that you're having a crack at these is very good, but just be aware and be careful that all of these rely on us knowing the difference of two squares is a special rule, bang, and also the fact that this is, in either form, a perfect square. Now, in knowing these two, I'm only going to call them two because this one I'm writing now is just a subtle difference. That's called the difference of two squares. And this is the form of a perfect square. So we can see here, if I just change pen colors, difference of two squares, perfect square, difference of two squares, perfect square, difference of two squares, perfect square, perfect square. So really it was practice in previous years to applying these rules, okay, in a general situation like I've done here, where there are no numbers. So that's the background, and that's where that's come from, Jess. Okay, so I hope that helps.